Before we got into answers, we did the pre-analysis. Before we get out of answers, let's do the verification and validation, which is very important since it's a systematic way of checking results. If I go back to the framework of what's under the black box, as I've talked about before, verification is, did I solve the model right? That is, whatever mathematical model I have, did I solve it correctly? And we'll check that. In contrast, validation is, did I solve the right model? That is, my model, is that an accurate representation of the physics? Now, this is the Euler-Bernoulli beam theory. Has been used for decades, and one would assume that it's for a cantilever beam, for example, it's a good model of the physical problem. But we don't have specific experimental data here, so we can't really do validation in the formal sense. So we'll focus on verification here. And here are the verification steps. The first thing to do are sanity checks, and we were checking this along the way. If the deformed shape makes sense, if the order of magnitude of the displacements of the stresses made sense, and they were all fine. Okay, so we've already done the sanity checks. Does answer solution honor the boundary conditions in my model? And the displacement constraints are zero displacement and rotation, the cross-section rotation at the fixed end at x equal to 0. This one was clear to us. This one, it seemed like from the how the cross-section was being displayed that the rotation was 0. So, and I've done other due diligence, so you might have to take my word on it that that's also the case. And so, this is something that we can be confident of. The third aspect of verification is, does the answer solution satisfy equilibrium? And so if the structure has minimum total potential energy, it means that it has to be in equilibrium. And specifically, whether the forces balance and the moments balance. And this is something we will check, and this is a very important check that you can do in any structural mechanics problem. So we'll do that. How well does the answer solution match hand calculations? And we checked for displacements and stresses, and it matched very well. So we'll say okay. Is the answer solution reasonably independent of the mesh? So the numerical solution that answers does is dependent on the mesh we provided, and the results should be reasonably independent of the mesh that we provide. So we will do, we will check dependence on the mesh. So that's another thing we'll do. So we'll do equilibrium, we'll check equilibrium, and we'll check mesh dependence as part of verification.